Good evening, my dear JEE warriors. Welcome to the Vedantu JEE English channel. This is your Captain Shreyas going live. I hope I'm audible and visible too. Let me know quickly in the chat box, and I hope you have all marked your attendance for this 1000 practice question series. And all these questions, we have tried to keep it as much as possible non-PYQs, because many of you have practiced a lot of PYQs. So these are PYQ model based questions, but as far as possible, you will not see that they have, been exactly asked in the previous year papers. We have tried to keep a mix of questions. And the best part is 11 syllabus, 12 syllabus separate. And this is a 1 week challenge, which many of you accepted. And I hope you are still keeping up to your promise. And otherwise, you would not be solving those 1000 questions. You need somebody to push you. And that's why your Captain Shreyas Sir is here. And if you want to get even more power in your, I would say in your weapons, then please visit any of our Vedantu learning centers. If you have one in your city, then make sure you visit it as soon as possible, because there are a lot of workshops being conducted. And yes, if you have your juniors and friends, let them know. All these cities, there are 11th, 12th standard batches, even foundation batches, which are running for, all the students out there. So make sure you have a visit at any of these centers and do a small inquiry. And yes, there is a grand launch in Patna with all the best teachers out there, right? So let's begin with the class. I hope you guys are all ready for it. Some of you are also asking that, sir, will you come here, because you took a 6-hour long class on another channel today. So some students were really doubtful about it. But let me tell you, Shreyas Sir is here, okay? So let's solve as many questions, even if we exceed 11 o'clock, 11:30. I hope you guys are going to be there in full energy, full strength till the end. Let's begin. Ready, guys? Yes, the remaining questions, Nikita, I have posted it up in the Telegram channel with the answer key. Everything is there. So please check it out. If you still have doubts, there is my Telegram channel, which is Shreyas, Captain Shreyas JEE NEET. It's an open group where students can ask doubts, etc. So on that Telegram channel, Captain Shreyas JEE NEET, you can ask me doubts if you have any, and many of us only solve the doubts, right? So do that. I hope that is fine. Right, here comes the first. I think this is an easy question. 3 particles each having certain charge are placed at the corners of an equilateral triangle. What is the electrostatic potential energy? Warm-up question for all of you. Whenever you have multiple charges and you want to find the potential energy of that system, then you take all the permutation combinations: potential energy of 1, 2, potential energy of 1, 3, potential energy of 2, 3. That's it. So it will be nothing but KQQ, which is KQ square. Distance is just the side length, so A, and this will happen basically 3 times. So it will be 3KQ square divided by A. All that is left now is to substitute the values. K value is 9 into 10 to the power 9. The charge value is 10 microcoulomb. So 10 into 10 to the power minus 6, and the whole thing divided by the side length, which is basically 10 centimeter, which is 0.1 meter. Even if you do not solve the question completely, you can still guess the answer. And if you remember my ignoring powers of 10 method, you will realize all these are powers of 10, decimals, zeros, etc. Forget it. 3 9s are 27. So answer should be 27. You don't even have to break your head over it. Yes, that is how you go. Everybody understood the technique? The technique is very simple. Just go with the powers of 10 and it makes your job look much, much easier, right? So moving ahead. So the same thing has been done right over here. Let's move on. A cube of side. Yes, a cube of side basically. Yeah, the video has started, Srikanth. Yeah, it's going to take quite some time for completing all these questions. We are going topic by topic. A cube of side length is placed in a field given by Ex by L I cap. The net flux through the cube if one of the corner is at the origin and the cube is placed on the positive side of all the axes. So let's draw the diagram first. Imagine this are the x, y, z axis. This is x, this is y, and this is z, and your cube is basically placed something like this, say, like this, like this, like this, like this, like this, and like this. Okay. So in such a case, if the electric field is only in the x direction and it is changing with the x coordinate, the top, the bottom, the front and the back face will not have any electric field. Correct? So the flux through the top, or the flux through the bottom, or the flux through the front, or the flux through the back, all of them is going to be big fat 0, because the electric field is only in the x direction. Look at this. If electric field goes like this, how is the flux going through this face? If electric field is going like this, how is it going through this face? So it can only go through the left face or the right face. Now the best part is, on the left face, basically we are talking about this face. On the left face, the x coordinate at all these points is 0. X coordinate is 0. So basically the electric field is 0 at all these points. Hence the flux on the left face is also going to be a big fat 0. Left face, electric field is 0. So that's why there is no flux also on the left face. There is only one face remaining now. There is only one face remaining now, and I hope you see that is this one. All the other faces were these things. This one, right? And then you had the base over here, right? And you also had the back part over here and all of that. So the only face remaining is basically this particular face. And at this particular face, the value of x is L. So the electric field at that point is E into L divided by L, which means it is just E. So the electric field at this particular location is present. So what is the flux on the right face? What is the flux on the right face? It is the field at that point, which is E, into the area of that point, which is basically L square. This is basically your area at that point, and this is basically your field. That's it. So EL square should be the answer. So EL square, which is option number 2. Yes, because all other faces had 0, 0, 0 flux. All the 5 faces had 0 flux. The only flux is there on the right hand side. How many of you got it? Cheppandi? Solanga? Everyone? Yes, Sanga Laukar? Yes, did you get this L square E? Understood? All the other sides, either the field was 0 or the field lines were parallel to the face. So that's why there was no flux. Moving on. Next question coming up on your screen. A charged particle enters point A and comes out from point B. Velocity vector makes an angle alpha here and beta over here. Ratio of the kinetic energies of the particles is asked. Yeah, let's see. Very good, Anugna, Yash, Manika, Bindula, ordinary person, Raja Rajeshwari. Yep. Let's move on. Now, over here, see guys, electric field is like this. So the force due to the electric field will also be in this direction, and this force is in the y direction. If you ask me what is the force in the x direction, the answer will be 0, because there is no field, there is no force in that x direction. That means the acceleration in the x direction is 0. That means the velocity in the x direction is going to be constant. I will use this concept very similar to projectile motion over here to predict the velocities at both these points. So think about it. At this point when you are entering in, the x component of the velocity will be sine. So it will be VA sine of alpha, right? That will be the x component of that velocity, right? Similarly over here, it will be nothing but VB sine of beta. So therefore, VA by VB will be sine beta by sine alpha, sine beta, sine 30. Sine beta is sine 30, sine alpha is sine 60. Sine 30 is half, sine 60 is root 3 by 2. So it will be 1 by root 3. That is your VA divided by VB. But that is not even the question. The question is ratio of kinetic energies. So Ka by Kb, which is half m VA square by half m VB square. Half m cancels. I will just have VA by VB whole square. What is VA by VB? It is 1 by root 3. So square it, answer will be 1 by 3. Yes, answer will be 1 by 3 depending on, I think KB by KA is asked, so it will be 3:1. So this was KA by KB, this was KA by KB. KB by KA will be 3 by 1. That is the correct answer. Is that clear? I am very good. 𝒒្��្તિ𝒔, thank you so much. Yep. Very good. Very good. Awesome. I'm very good, everyone. Yep, I'm very good. Pradeep, I'm very good. Sir, no, it's not sine, sir, cos. No. Read the question carefully. See the angle, how it is marked. Be very, very careful, my dear friends. Over here, the velocity was like this. The velocity VA is like this. And this angle is alpha. That means this is also alpha. That means with the vertical, this is alpha. So when you split the components, this will be cos component and this would be the sine component. This will be VA sine alpha. Lot of students made a mistake here in this question. They took cos component. See, it is made with the vertical, not with the horizontal. Is that clear? Same thing applies on that side. Common mistake which many students end up doing in this. Let's move to the next question. Oops, what is this? Why has the answer come on this side? Okay, the answer only came on this slide. All right, fine. So in the option slide, there is option marked over here. Very good. Anyways, so I don't have space now. I'll just explain it to you like this only. So there is a charged sheet and basically it is going to create electric field, and there is a thread which is attached to a bob, and basically the ball over here is also charged. The charge here will repel this charge, so it is making an angle. So question is, the surface charge density on this particular sheet is proportional to which part of theta, or which ratio, trigonometric ratio of theta? That is the question. So because this is a charged sheet, what will happen, my dear warriors? Because this is a charged sheet, it will create an electric field like this. It will create an electric field like this. So this electric field will create an electric force on this particle like this. So the force will be Q into E. So the force will be Q into E. Apart from this QE, the other forces are basically your mg and basically the tension. Now this tension will have two components, because if you notice with the vertical, this is angle theta. So the tension's sine theta component in the x direction, it is balanced by this force which is basically QE. Secondly, in the y direction, the tension's cos component is basically balanced by mg. So dividing both of them, you will get tan theta is equal to QE by mg. But wait a minute, Q is there, mg is there. This electric field is sigma by 2 epsilon naught. That is basically tan theta. So can you clearly see that sigma is proportional to tan theta? So the charge density is proportional to what? The tan of the angle, which is option number D out there. I hope this is clear. Very good. Thank you so much, Sania Sani, for all the love from Kerala. Means a lot, and I feel very happy when students from Kerala come, because a lot of students are there from Tamil Nadu and Andhra over here, and there is a good amount of people who prepare for medical entrance exams in Kerala, and when students prepare for JEE from Kerala, I feel very, very happy about it. Very good. Yes. So let's begin with the next question coming up on your screen, and here it is. There is a spherical conducting shell of radius r, charge q. Another charge is placed at the center of the shell. The electric potential at point P at distance r by 2 from the center of the shell is how much? Okay, let's draw the diagram. Without that, there is no point about this. So this is the conducting shell of radius r, and it has a charge q on it. Another charge is placed at the center of the shell. So let's say it is how much it is? It is given. Another charge is placed at the center of the I think it should be q if I'm not wrong. because that is the only variable I can see. The electric potential at a point P at a distance of r by 2 from it, at a distance of r by 2. So you go at a distance of r by 2 from here. So at this particular point, what is the potential is the question. So the potential at that point will be the potential due to the charge Q plus the potential due to the shell which has the charge small q. Now, due to the capital Q, because it's a point charge, directly use K, Q divided by distance. Distance is R by 2. That's as simple or straightforward as that. When you are inside a shell which is charged, the potential everywhere is the same. So, that is why it will be K small q divided by the radius of the shell. A lot of people say, sir, distance is not given. Is it R by 2? No, it is simply R. So that is the answer, my dear warriors. 2 goes on the top. So you should be left with this as the answer. I mean, that is what you can see right over here as well. So in fact, K is common and even R is, or you can just write K as 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. This 2 goes on the top, so it will become 2Q, and this R remains as it is. And then over here, K is nothing but 1 by 4 pi epsilon naught, Q is there, and this R is also there. So it's exactly option C for Captain Shreyas. Is that right? Everyone with me on this? Why should we add that? See, the reason for that is, the question is, what is the electric potential at this point? So electric potential is a scalar quantity. Every charge's potential will add up, whether it is positive voltage or negative voltage. It will just keep on adding up. So the charge at the center will also give potential. The charge on the surface will also give potential. So you just do scalar addition to find the total potential. I hope this is clear. Hello Rihanna Minya, welcome. Got it Abinya, awesome. Great. Moving on to the next one. An electric dipole is placed at an angle of 30 degrees, right? And what happens now is that it is placed in a non-uniform field. What do you think will the dipole experience? That's the question. So if it is a non-uniform field and let's say the dipole is making certain angle of 30 degrees, this is P. So this is electric field. So that dipole will experience force like this on the positive charge, and on the negative charge it will be exactly opposite, but here the field is stronger. So this force is more, this is less. This is basically stronger. This is basically going to be stronger. So clearly net force is not 0 and even net torque is there. It is also not 0. Why are the forces not cancelling? Because of this important word, non-uniform electric field. In uniform electric field, the net force is 0. Non-uniform field, the forces will not be the same. Why? You will see that the field is very weak over here because they are very far away. Here it is strong. So that is the reason why you will see in a non-uniform field, the net force will not be 0. Got it, my dear warriors? Very good. Many of you have given the correct answer as C. Yes. Very good, 𝑬𝒐𝒐𝒏, very good, 𝒎𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏𝒏 torque as well as translational force. A lot of people think there is only rotational force. No, there is both kind of forces. It is at an angle also. It is kept at an angle also. So there will be a torque. You can clearly say there is a torque acting on it. Okay. Let's go to the next question. The electric field in the region is radially outwards is given by Kr. The charge contained in this particular sphere is how much? Now, the moment I see this question, yes, you can join the class now, Viramna, because whatever part you have missed, you can watch the lecture later on. This is question solving series. It's not a concept explanation. So no matter where you join, you can understand it. So this electric field formula reminds me of something. It reminds me the field inside a charged sphere. Do you remember the formula? It was also proportional to R. The electric field inside a charged sphere was given by K, and then you had basically that K was nothing but 1 by 4 pi epsilon naught charge into small r. divided by R cube. It's very similar. These people are K and this electric field is this. So if you basically compare them, and write this electric field as Kr, if you write this electric field as Kr, this R and this R will cancel. Bring all these gentlemen over here. So K into 4 pi epsilon naught into R cube will be just Q. That's it. I think you have got the answer. So option basically B is correct. So here R is given as the radius is given as A. So you can substitute the value of R as A because the radius of the sphere is given to be A. Right? So that's it. You can see option B is correct. Do you understand what is the trick I used? Otherwise, it would be a problem. Right? Perfect. Moving on. Yes. So this is going to be a homework question. I'm going to keep few homework questions from each chapter. So we cover maximum chapters as possible. Let me tell you, answers, etc. everything I have kept it on the slides ahead of it. Right? So make sure you are checking the PDF which I'll be sharing on the Telegram channel. Moving on to the capacitor part now. Here comes the first question of capacitors. There are 4 capacitors which have, come on guys, capacitors, get ready for it. Yes, get ready for it. There are 4 capacitors which have same plate area, dielectric medium, but different distances between the plates of the capacitor. The graph is plotted by between the charge and the potential as shown. Which of them will have a large plate separation? That is the question. Okay, charge versus voltage is given. So we all know Q is equal to CV. Capacitance is epsilon naught Ka by D, and this is V over here. Permittivity is same, K same, area yes, D not the same, different distances. So from here, if I notice Q by V is equal to some constants are there divided by D. Q by V is nothing but the slope, of Q versus the voltage graph, and it is inversely proportional to the distance. So which has large plate separation? That is the question. So if distance is more, the slope is basically going to be less. Distance is more, then the slope is going to be basically very less. So which has the least amount of slope? This one. This has the least amount of slope. So this will have the highest basically separation. I hope this is very clear. Everybody understood this particular point? Some of you are saying which of them has large plate separation. Guys, think carefully again. Q is equal to CV. These are 4 capacitors. Area is same, right? K is also same, but different distance between them. Q versus V, if you plot, you will get the slope, y-axis by x-axis. So that will give you some constant by D. That means this number is inversely proportional to D. So if the distance is basically large plate separation, the slope has to be less. That means it has to be option A. Is that okay? I hope this is clear. Yes, be really careful. Yes, some of you answered A. Be very careful. Moving on to the next question coming up on your screen. Here it is. A parallel plate capacitor with air in between the plates has a capacitance of 9 picofarad. The separation between its plates is D. The space between the plates is now filled with 2 dielectrics. One of them is 3, and thickness D by 3. Other has K2 as 6 and thickness 2D by 3. The capacitance of the capacitance is now going to be. Okay, so original capacitance was 9 picofarad. Great. Now, thank you Guna 46 rider. Glad to know that you are a regular student. Original capacitance will be epsilon naught A by D, which is given to be how much? 9 picofarad. Now what happens is this: you take that capacitance and you put it up with 2 different materials. One is having 3 as the dielectric constant, One is having 3 as the dielectric constant, and the other one has a dielectric constant of 6. Other one has a dielectric constant of basically 6. This is basically d by 3 if I'm not wrong, and the other one is basically 2d by 3. Now the value of such a capacitance, there is a direct formula. The new capacitance is epsilon naught A by, instead of d you put individual distance and divide it with the dielectric constant. What do? You divide it with basically the dielectric constant. So first distance is d by 3, divide it with the dielectric constant, which is 3. Next distance is 2d by 3, divide it with the dielectric constant, which is basically 6. So it will become epsilon naught A, d is common over here, just take it away, 1 by 3 3s are 9, so 1 by 9 over here, plus 2 goes with 6. 2 goes with 6 3 times, right? Everybody with me? What has happened to the chats? Are you able to see me? I hope I'm seeing. Okay, are my chats everything visible? Yeah. Okay. All right. Okay, great. Yeah, 1 by 9, and this 2 and 6 will cancel. 3 3s are 9 again, so this will be 1 by 9 again. So this will become epsilon naught A by d is 9 picofarad. From there, do you see this? This whole thing, what you are seeing, is exactly 9 picofarad. Perfect. The rest of the things, 1 by 9 plus 1 by 9 is 2 by 9. Is 2 by 9. So goes on the top. So 9 into 9 divided by 2. 9 into 9 divided by 2, which is 81 divided by 2. 81 divided by 2, which is basically 40.5 picofarad. That is the straightforward answer. Yes, answer B. B for IIT Bombay is correct. B for IIT Bombay is correct. You should know this direct formula, else what will you do? You will waste your time. Find capacitance of this. Find capacitance of this. This is in series because they are one after the other. And when capacitors are in series, don't add them. It will be C1 C2 by C1 plus C2. Unnecessary lengthy method. Use this direct formula which Shreyas Sir is giving you. Epsilon naught A in the numerator. Distance by dielectric. Distance by dielectric. If more slabs, air, beer, whatever is there, just d by k, d by k, d by k. Keep on adding that till you reach the last slab or the last gap. Okay, so if it was air, then you will divide it with 1. Keep that in mind. You will divide it with 1. So this is a simple way of doing it. The charge on the capacitor is asked. This is again a straightforward question, guys. So first of all, charge on which capacitor is asked? 5 microfarad. So for that, let's just consider only this top part. Maybe I'll just duplicate this slide for now. And see, guys, what happens over here. This 6 volts is going to be up. My gosh. This 6 volts is going to be applicable. 6 volts is going to be applicable for this branch also, because this branch and this branch both are in parallel. Okay. Now, what is the effective capacitance of this part over here? So first of all, these two people are in parallel. So when in parallel, just add them, 2 plus 5, which will make it 7 microfarad. Now this entire branch, let's go ahead with this. So you have 3 microfarad, and then you have basically how much? 7 microfarad, and together the voltage across them is 6 volts as needed. So if you combine them into one single capacitor, and the same voltage will be applicable, 6 volts. What will be the capacitance, guys? It will be C1 C2 by C1 plus C2, which is 21 by 10 microfarad. Everybody with me? 21 by 10 microfarad. I hope this is clear, everybody. Right? Now, once this is done, what you will do? You will find the charge on this. You will basically find the charge on this. So the charge on this will be CV. Will be basically how much? CV. Right. So C is basically 21 by 10 micro, and the voltage is basically 6 over here. So 6 goes with the 2 3 times, 10 goes with the 2 5 times. So 21 into 3 is basically 63 by 5 microcoulombs is the charge on this capacitor. Once you go in series, the charges are the same. So the same charge Q will be here also and the same charge Q will be here also. So on this 7 microfarad capacitor also, you have the same 63/5 microcoulomb. Now, when you split it up into these two capacitors, then the charge will also get divided. We know that in these two, the voltages will be the same. The voltages will be the same, and voltage is nothing but Q by C. So Q on 2 micro upon Q upon 5 micro. Sorry, what did I just do? Charge voltage is Q by C. Q is Q2, C is 2 micro is equal to Q on 5 upon capacitance, which is basically 5 micro, because the voltages are same in parallel. So therefore you will get Q2 by Q5 is equal to 2 by 5. But do not forget Q2 plus Q5, the total charge on this is this one, is basically capital Q, which is 63 by 5 microcoulomb. 63 by 5 microcoulomb. That's it. I got the answer. Now what to do? From here I know Q2 is equal to 2 times Q5 divided by 5. Take this Q2 and substitute it over here. So 2Q5 divided by 5 plus Q5 is equal to 63 by 5. So 2 plus 5 is 7. So 7Q5 divided by 5 is 63 by 5. 7 and 63 go 9 times. This 5 and this 5 also goes over here. So I think you should get this as 9. You should get this as 9. Yes, we are getting it as 9 only. This slide was not even needed. Directly I got from here, guys. I hope you can see that Q5 is equal to 9, right? So the answer should be 9 microcoulombs. Is that clear how we did this? First, keep on making it smaller, find the charge and then go reverse. That is how exactly these kind of problems progress. You make it small, condense it, and again go the exact reverse. From the equivalent, split it. Whenever in series, charges are same. Whenever in parallel, voltages are same. Just use this theory and you will get the answer. Yeah. Class line wastage. Now, is it? Is there a class scheduled by mistake? Oh my god, please don't tell me. Hey, nothing is scheduled, man. Don't give me tension, full on. 11th class wasted. Nothing is scheduled. At least nothing that I can see of. Okay. Let's go ahead to the next one coming up on your screen, and here it is. Two capacitors having capacitances having this breaking voltage are combined in series. The maximum charge they can store individually in the combination. This is a brilliant type of question which is usually again asked in many exams. Now first of all, remember, whenever they are in series, it's given, right? They are combined in series. What happens is the charges are the same. The charges basically are going to be the same. That is something which you should keep in mind. If you just talk about this capacitor who has a breaking voltage of this much, the maximum charge on the first capacitor can be Q is CV, C is 8 milli, and voltage is basically 20. So it is 160 millicoulomb. Similarly, if you talk about this capacitor who has a maximum voltage of this much, the maximum charge which can be stored is basically going to be capacitance is 16 milli and voltage is basically 80, right? I hope this is clear. So this is just going to be 148 and 0 millicoulomb. Now out of these two, this can store more charge, this can store less charge. So if you go by the logic saying, sir, maximum charge has to be stored, sir. So just imagine this now. Just imagine this. there is this capacitor here, there is this capacitor here. If they are connected in series, which of the following do you think the charges can be stored without any breakdown? Imagine 1480 over here, 1480 over here, versus, because they are in series, charges will be same, versus 160 here, 160 here. Which one do you think is more possible? Which one do you think is more possible, guys? Come on, think about it. If you go by this, maybe the capacitance 2, might be able to handle it well, but capacitance 1 can't handle anything beyond 160. So it will break down. It will break down. So it can't handle. Maybe this can handle. Maybe this can handle. But we want both to be able to withstand that charge. So this is the only possible option. I know this capacitor is holding much less charge as compared to its maximum capacity, but the problem is, even if you make it 161, this capacitor can't hold the charge. That is the problem, because this guy's limit is this. So this is like the limiting reagent, like you study in chemistry, right? So that is the answer, 160 millicoulomb. And I often ask my students, if I have 5 POWs plus 5 vadas, you get basically 5 vada pav. 5 vada pav. Agree? But if you have 5 POWs plus 3 vadas, what do you get, my dear warriors? What do you guess, my dear warriors? You will get 3 vada pavs. You will get 3 vada pavs. Why? Because each vada will go with 1 pav. The extra 2 pavs, why will I eat it like that? I need with the bread something. I need a sauce. I need some chutney. I need some vada. I need some sambar. I need something. So those 2 pavs are going to go waste. So it will be 3 vada pav. Understood, my dear warriors? That is what a limiting reagent is. What is breaking voltage, Pradeep? Basically, the voltage after which the electric discharge will occur, the charges will flow like a lightning, there will be a spark created, the capacitor will burn out. Just like a bulb will burn if you pass excess electricity in it, same way that is a breaking voltage for a capacitor, after which it might burn, it might create sparks, it might damage the capacitor. Understood, my dear warriors, how this works? What is the meaning of this? Very good, excellent. So moving ahead now to the next question coming up on your screen. 2 identical capacitors are joined in parallel, charged to a voltage V and then separated and connected in series. The positive plate of one is connected to the negative plate of the other. The charges on free plates destroy, charges on free plates enhance, the charges stored in the system increases, the potential difference in the free plates becomes 2V. If you answer this question, 99% guaranteed. 99% guaranteed. Karthik, every session 100 questions are given to you. We will solve many questions here, few questions as homework. The total target for this week's challenge is 1000 questions. Every week we are taking up challenges. We completed 2-week challenge, then this is 1-week challenge, and last week is remaining. We will be taking up more challenges. Think about it, my dear warriors. If you take 2 capacitors, charge them in parallel, basically like this, charge them in parallel like this. So this will be positive, this will be negative, this will be positive, this will be negative. Now you separate them out. Okay, fine. They are like this, positive, negative, and separated and then connected in series. Positive is connected to the negative of 1. Positive of 1 is connected to the negative of the other, like this. Then what do you think? Guys, will happen over here? If this is the final connection, will the charge go up? No, there is nowhere the charge can go. Where will the charge go? Nowhere it can go. Nothing can happen. So if each one of them had a voltage of V each, because they were charged by this battery, this will have voltage V, this will have voltage V. So the total voltage will be 2V. Charge can't go anywhere. Where will it go? It is clearly mentioned that the positive plate of one is connected to the negative plate of the other. Not all the terminals, only one terminal. Only one terminal. So many people make a mistake there. So the correct answer is potential difference in the free plates becomes 2V. You can think of it like that. The potential difference on the free plates. Which are the free plates? See, these are the plates which are connected. These are the plates which are basically connected. These are the plates which are connected. Whereas these plates, this one and this one, they are free because they are not connected to anything. They are basically free plates. So the voltage difference between them is 2V. Did you get it? Many students wrote answer 1. That's why I said 1% only of the students will be able to solve. 99 percentile target students will be able to do this. Okay, it's a good question, but now you know it. Hopefully, you will get 99 percentile. Keeping the voltage of the charging source constant, what would be the percentage change in the energy stored in the parallel plate capacitor if the separation between its plates were to be decreased by 10%? That is the next question, guys. Let's see how do we do this. First of all, okay, the plates separation is decreased, energy is asked for a parallel plate capacitor. So the energy stored in a capacitor is half, keeping the voltage constant. So half CV square, because voltage is kept constant. It is clearly mentioned. Or else I could have used half Q square by C also. But then charge might change. Capacitance is epsilon naught A divided by D, and this is V square. Let's say I call this initial energy. Then the final energy, my dear warriors, will be half epsilon naught A V square, but the distance will be different if the separation is decreased by 10%. So the new D will be D minus 10% of D. It has been decreased by 10%. So it will be D minus 0.1 D, which is basically 0.9 D is the new D. So instead of the D1 over here, you can just put 0.9 D over here. So now comes the next part. What is the percentage change? So that's it. So the percentage change. So the percentage change will be, look at this minus this upon original. So UI minus your UF by your original. What is original? UI, this into 100. That is what is going to give me the percentage change. Now if you notice, in all these things, half epsilon naught A and V square is common, even D is same. So the first term will just be 1 minus, even the denominator will be just 1 only. Here you have 1 by 0.9, that's it. Here you will have 1 by 0.9, and this whole thing will be multiplied by 100 to get it in percentage. Will be into 100 to get it into percentage. Did you understand what I just did? Right? Half is same, epsilon A, D, V, everything is same. So this will be just 1 by 1 minus 1 by 0.9 by 1 by 1, like this. So it is 1 minus 1 by 0.9 into 100. Just check it out. If you get it as 11.1% approximately, that is the final answer. So approximately you should be getting it as 11.1%. Is that right, everyone? That is the answer. Some of you are asking me, sir, why can't we use the error formula? Answer it in the chat box. Why we can't use error formula and directly, say that, hey, wait a minute, U is inversely proportional to D, or U is directly proportional to D raised to minus 1. So delta U by U is a delta D by D. So error in D is 10%, error in U will also be 10%, but that is not the correct answer. What is the problem? The problem is this percentage error is more than 5%. Usually when the errors are more than 4, 5%, 6%, then these formulas are not applicable. You have to go via the basics. You have to find the actual change and then find the percentage change. So do not use that over here. These kind of traps are always laid by the NTA people. Yes, definitely, Vatsalya. Immediately after JEE Mains, we will be starting EPSAT series also for all of you. But remember, JEE Mains is very crucial because you will get much better colleges, and I feel that you should always target the best, right? So moving on to the next one. The capacitances are connected, C1, C2, respective voltages are V1, V2. If they are connected by a thin wire, then the loss of energy will be how much? So this is another kind of question which is usually asked. So each capacitor had its individual voltages V1 and V2. Now what happens is you are connecting it by a thin wire, so there will be a loss of potential energy. Now this kind of question, or in fact I had put one more question over here also. This kind of question, there is a capacitor charged to 220 volts and then it is disconnected and connected to another capacitor. How much energy is lost? These kind of questions are very, very common. Whether you solve this or whether you solve this, it's one and the same kind of thing. These kind of questions are very, very common. So we can take anything. Let's say for example, we take this question. Same kind of things are there. Many times this pattern is repeated. Loss of energy when capacitors are connected to each other. So say for example this one, right? So this 5 microfarad capacitor is connected to a basically 220 volt battery. 220 volt battery. I can call this capacitance as C and this battery voltage as V. Okay, battery voltage as V. Then the charge on it will be basically CV. Charge on it will be basically CV. Now it is disconnected from the supply. If it is disconnected from the supply, that means the charges are still going to be there. It will still have that Q charge. And now it is connected to another uncharged capacitor. Another uncharged capacitor of capacitance half of the previous one. So this capacitance, if I call it as C, this is C by 2. There is no charge on it. There is no charge on it right now. We're just going to connect both of them. So finally, what will happen? These two capacitors will be like this. This will be C by 2. This will be C. Because they both are in parallel, because the voltages are same, I can treat it like one single capacitor of capacitance C plus C by 2, which is 3C by 2. In this process, whatever charge was there will get redistributed. Maybe this might get Q1, this will get Q2, but the total charge, that means basically Q1 plus Q2 will still be the original Q. So this equivalent capacitor will also have the same charge. It will also have the same charge. This is the flow of thought. This is the logical step-by-step deduction you will need for these kind of problems. Always they will be in parallel, voltages will be same, total charge will be conserved always, and because they are in parallel, you can just add the capacitances. Now, what do you do next? What do you do next? Basically, you know the initial energy, you know the final energy, just subtract the two. So the initial energy will be half CV square. The final energy, UF, will be half capacitance Q square by C I will do. So Q square by C. C is basically 3C by 2. Q is basically CV. So it will be C square V square by this 2 as it is. This 3C by 2 over here. 2 cancels. CC cancels. So it will be CV square by 3. CV square by 3 here. CV square by 2 over here. So therefore, delta U will be CV square by 2 minus CV square by 3, which is CV square. LCM is 6. So this will be 3 minus 2, which is 1 by 6. So CV square by 6. Now substitute all the values over here. You know the capacitance, it is how much? 5 micro. 5 micro. Voltage is how much? 220, and this divided by 6. That's it. So that will give you basically the answer. So this will be 220 whole square. 220 whole square. That will give the answer as close enough to 4. It will give the answer close enough to 4. Is that clear, my dear students? Is that clear, my dear students? Yep. Very good. Okay. Awesome. Awesome. Shall we go ahead? Shall we go ahead, everyone? Yep. Okay. Let's go. Next one. So same way you can solve this question also. Again, both the capacitances are in parallel. The equivalent capacitance will be C1 plus C2. Initial energy will be half C1 V1 square. Okay. I hope you will be able to do this also. Initial energy will be half C1V1 square plus half C2V2 square. Final energy will be half Q total by C effective, and this will be square. This charge will be C1V1 plus C2V2, and this effective capacitance will be C1 plus C2. So basically after this you just have to subtract them to get delta U. So solve this and you will get the answer as this one. Solve this and you will get the answer as option C. I have given you the steps. Please proceed with the proper calculation after this. Okay, mainly steps are important. Now I have kept some homework questions on capacitances with solutions, of course. So please make sure that you solve the capacitor questions. I have kept few questions on capacitors. Okay, 2-3 questions. Going on to current electricity. Ready for it, I hope. Ready for current electricity, my dear students? No. Charging, discharging is not there. Charging, discharging, JEE Mains is not there. Don't study that. Don't waste your time. Bhaskar, assembling all the South Indians. Very good. Okay. Moving on to the next one. A wire of resistance R is cut into n equal parts. These parts are then connected in parallel. The equivalent resistance of the combination will be, okay. So a resistance R is cut into n parts. So each of that part will be basically R by n. Everybody with me? Okay, what you do after this? You have connected them in parallel. So like this. All these resistors R by N, you have basically connected them in parallel. Okay, you have connected them in parallel. So 1 by Rp will be 1 by R by N, like that n times. So it will be n divided by R by n. So it will be n square by R, but that is 1 by Rp. So Rp will be reciprocal of that. So it will be R by n square. R by n square, that is option number D, of course. Got it? How we did this? This kind of questions are also again common. You cut some resistors, join them. The resistors are joined, you cut them. So these kind of combination questions are usually asked. Sometimes they combine it with power also. The heat loss of this wire was H. You cut those pieces and you connect it to the same battery. What is the new power loss? So power is V square by R. So if the resistance changes, power loss will change. So accordingly, those kind of questions can be solved. They can ask you for current. What is the new current? What is the new voltage? What is the new power? What is the new resistance? All these are standard patterns of questions asked in JEE. Next one, find out the value of the current through the 2 ohm resistance. How do you do this? This is a simple question. By the look of it only, you will be able to solve. Just looking at it, you can solve this, guys. How many of you can answer it? Then you are going to get 90 percentile, 100% guarantee. I'll come to Madhura and Nitish. I am very much held up with your JEE preparation. Did you just see 6 hours class I took on the NEET English channel? Just ended the class at around 5:30 or so. And now I am here just after 3 hours, just after having my lunch. I didn't even sleep or anything. And just make sure that the questions were there properly, and that's it. I came over here. I have not even had my dinner now. I had my lunch at 5:30, by the way. I had my lunch at 5:30. I saw these questions. Now I'm going to have my dinner at, I don't know, 11-12 o'clock. So yes, the answer is going to be 0. Pakka? Yes. Why? Because why will the current flow? If the current goes, what will it do here? If the current goes here, what will it do here? Can't go. If it goes, it has to have a return path. It will be an open circuit otherwise, so no current can flow in this. It has to have a return path. No return path. If something goes, it has to come back. Remember, that is the logic behind it. Is that okay? Clear? Pakka? Okay. Yes. When it is said to be short-circuited means, look at this. Imagine a resistor is here like this. Some resistor is here, maybe there is some battery here, something like that. Some capacitor here, Okay, some resistor is here, some complex circuit is there. Okay, like this, some resistor here. Now, if somebody takes a wire and does this, this resistor is said to be shorted. This resistor is said to be what? Shorted. So this is said to be shorted. The meaning of shorting is the 2 points across the device have the same voltage because you have connected it with a wire. Here, this resistor is basically open because there is no return path. There is no path of return. Understood the difference between shorting and opening circuit? Clear? Okay. Moving on to the next one. This question will be very nice because I'll tell you why. At 300 Kelvin, the resistance is 1 ohm. At the temperature at which the resistance becomes 2 ohms. I have seen many students do this using this formula. RT is equal to R naught 1 plus alpha delta T. RT, resistance is becoming 2 ohms. R naught is basically 1 ohm. 1 plus alpha is 0.00125 into temperature difference. That means T minus 300. If you do this, this is wrong. Why is it wrong? Tell me. Resistance initially 1, resistance finally 2. 1 is 1, alpha is given. Change in temperature, T minus original temperature 300. This is wrong. This is going to be wrong. Why is this wrong? Just tell me that. Why is this wrong? Tell me that. Thank you, Vatsalya. The reason why it is wrong is this R naught. This R naught can't be any random resistance at any random temperature. It has to be at 0. It is measured from 0. So that is why this is not correct. Be very careful. So the actual correct equation would be 1 ohm is R naught, which I do not even know at 0, right? How much it is? 1 plus alpha delta T, and that delta T will be basically 300. I hope this is clear. Everybody with me? Yes? Very good. Very good. And the next equation will be 2 is equal to R naught 1 plus alpha into T, which I do not know. Now this is fine. You can divide both of them. Divide this with this to solve and get the correct answer. So when you divide them, what do you get? 1 by 2 is equal to 1 plus 300 alpha upon 1 plus T alpha. Cross multiply. So 1 plus T alpha will be 2 plus 600 alpha. I want T, right? So T alpha will be 2 minus 1 is 1. 1 plus 600 alpha. So T will be 1 by alpha plus 600. Alpha value you already know, it is 0.00125. Substitute, you will get the answer as 1127. The same thing has been done over here. So you will probably get this as the answer. Is that okay, my dear warriors? Understood the logic? Many students make a silly mistake. Do not do this. Warning, warning, don't use this. The problem is this R naught has to be at 0. This R naught has to be at 0. Got it? Everyone, let's move on to the next one coming up on your screen. Okay. Yes. Why can't it return? How can in the same wire different? Think about it. In the same wire, how can current go also and come also? It's a one way. In a wire, if the current is going in a particular direction, it's blocked. Current can't come in the same wire in the opposite direction. It has to use a different wire. It's like a narrow road where only one vehicle can go. Once a vehicle is going, other vehicle can't come in the other direction. Is that clear? Okay. RCLC circuits, please watch my Pathfinder series. Okay. Moving on to the next question. Two identical cells connected in series, 1 ampere current through 5 ohm resistance. When they are connected in parallel, they send the point current ampere through the same resistor. What is the internal resistance of the cell? Two situations. Cells connected in series first. So this resistor, this cell, this resistor, okay, external resistor like this. Current is 1 ampere. So current over here is E plus E, which is 2E, divided by R plus R, which is 2 small r plus capital R. This current is 1. EMF not even given. Okay. Resistance through 5 ohm resistance. Okay. So this is 2 small r plus 5. Multiply this. So it will become 2r plus 5 is equal to 2E. I will keep this as equation number 1 as it is. Is that okay? I just kept it separately. Perfect. Now what I will do, I will go for the parallel part. One cell, one resistance internal, one cell, one resistance internal like this, and connected to the external resistance. So in this case, what will be the current? By the way, the EMF equivalent will be E only. The resistance will be R by 2 plus R. This current is given to be 0.8. Do you understand why it is E? Because they are in parallel. E and E parallel will give the same voltage, right? Same voltage. And parallel resistance will become half. That's why R by 2. This R by 2 is in series with this R. That's why I have added to find the total resistance. Is E divided by R by 2 plus R cross multiply. So it will become 0.4 small r plus 0.8 capital R is equal to E, but I don't like it like this. How about this? Multiply it with 2 so that it will also become 2E. So it will become 0.8 small r plus 1.6 capital R is basically 2E. Now this is equation 2. Now from equation 2 and 1, see what will happen. This is also 2E, this is also 2E, this and this should be equal. So from there 2R plus 5 should be equal to 0.8 R plus 1.6 times of R. So from this you will get R in terms of capital R, but even capital R is given to you. Yeah, capital R is given to you. We'll put that as well. So we'll see what will happen. This will take it on the other side. 2 minus 0.8 is 1.2 times of R is equal to 1.6 R minus 5. This R, put it as 5. This R, put it as 5. You will get the value of R. The value of R that you will get is a 2.5 ohm. Is basically 2.5 ohm. That is what you will get. Is that okay, everyone? Clear? Shall we go ahead? Shall we go ahead to the next one? All right, let's go. Why is the answer only over here? Wow. Okay, anyways, the answer is here already, so ignore this answer. Okay, we'll just try to see how to solve this question. A battery has an open circuit voltage difference of 6 volts. If a battery has open circuit voltage of 6 volts, that means EMF is basically 6 volts. When a load resistance of 60 is connected across the battery, the total power, okay, so you take this battery of 6 volts, it has some internal resistance, and you connect it to an external resistance of 60 ohms. The total power dissipated by the battery is 0.4 watts. Total power is basically 0.4 watts. That is what the question is. So what is the load resistance so that maximum power will be dissipated? Okay. So first of all, in this particular scenario, the power will be using V squared by resistance formula. The power is 0.4. Voltage is 6, so 6 square. R equivalent is basically 60 plus R. 60 plus R. Is that right, everyone? V square by R equivalent, both the resistors are in series. So 60 plus R. So 60 plus R is equal to 6 square, which is 36, divided by 0.4. 36 goes with 4 9 times, so it will become 90. So small r will become 90 minus 60, which is basically 30 ohms. So this is the internal resistance. Now it so happens that if I know the internal resistance of this cell, which is basically 30 ohms, how much load will you connect so that maximum power will be dissipated in this hour? Using maximum power transfer theorem. Maximum power transfer theorem, external resistance should be the internal resistance. That means it should be 30 ohms. Hence the answer is 30. Hence the answer is 30. Did you understand what is the logic used, my dear warriors? Very good. Very good. Excellent. Let's move to the next question then. Let's move to the next question, everybody. Cool. Here comes the next question. This is on a meter bridge. A resistance of 2 ohms is connected on the gap of a bridge. The length of the wire is 1 meter and the unknown resistance greater than 2 ohm is connected across the other gap. Okay. Okay. A greater resistance than 2 ohm is connected across the other gap. When these resistances are interchanged, the balance point shifts by 20. There is no end correction. What is the unknown resistance? That is the question basically. Okay. So, first of all, just visualize this. Imagine this is 2 ohms and in the other gap unknown resistance is basically X. Alright. And unknown connected. Now I don't even know the length. Okay, so I will not use the word X, I will use the word R only over here. And here, this is how the meter bridge is. This is how the meter bridge is. Let's say this is X and this is 1 minus X. This is 1 minus X. This is the null point. So from here, 2 by R is basically X by 1 minus X. 2 by R is basically X divided by 1 minus X. Everybody with me? Cool till this point? Perfect. Now, instead of using 1, I think it is better to use 100 because 20 centimeters is given. So I will use X also in centimeters. I will use X in centimeters. This is also in centimeters. So technically then this instead of 1 minus X which was in meters, I can put it as 100 minus X. I can put it as 100 minus X both in centimeters. So this will be also 100 minus X. This is my equation 1. Now second time what happens? Second time what happens? You put R over here. You put R over here and you basically put 2 over here. Obviously the balancing point will shift. Obviously the balancing point will shift. It is clearly mentioned unknown was more. So the one which is higher will have more length. So that means this point is going to shift over here. This point is basically going to shift over here. By how much? 20 centimeters. So this will become X plus 20 and this will become 100 minus X minus 20, which will make it 80 minus X. 80 minus X centimeters. This is X plus 20 centimeters. Is that clear, my dear warriors? Is that clear, my dear warriors? This length reduced, this length expanded. Okay. So over here, I can say X plus 20 upon 80 minus X is equal to R divided by 2. Is basically R divided by 2. Here you have 2 divided by R. So now you know this is 2 by R. If this is 2 by R by 2 will be X by 100 minus X. So this will be X by 100 minus X. And this will be X plus 20 and this will be 80 minus X. These both will be equal. Now you just solve this. You just cross multiply them and solve for X. That part I leave it up to you. So it will be X plus 20 into 100 minus X is equal to X into 80 minus X. 80 minus X. If you are wondering whether it will be quadratic equation, let me tell you, it will not be a quadratic equation. It will not be a quadratic equation. You know why? Check this out. X into X is X square with a minus sign. X into X with a minus sign is again minus X square. So it will not be an actual quadratic equation. The best part is it will be a linear equation. It will be a linear equation. So you will get X directly over here. Check it out if the value of X comes out as 3 ohms. Solving this, you should get directly X as 3 ohms. Understood the logic? First time, ratio of the resistance is the ratio of the lengths. Second time also same thing, but the lengths have changed because you have shifted it by 20. So if you increase this by 20, this will decrease by 20. So that's why 100 minus X minus 20. Just simple mathematics after this. Simple mathematics after this. Is that okay, my dear warriors? Can we move ahead? Can we move ahead to the next question coming up on your screen? Okay, yeah, this is red, so it's a homework question. All these things, this one, I have kept some homework questions for all of you from current electricity. Moving on to magnetism, magnetic effects, all these things, all the chapters of magnetism clubbed together. Ready for this? Ready for this? Ready for this? Perfect. Okay, moving on. A proton, charge, circular orbit, field with energy 1 mega electron volt. What should be the energy of the alpha particle of this much mass so that it can revolve around the same radius? Okay, radius is equal to mv by qb. Mass into velocity is momentum. Momentum is root of 2mk, and this is qb. What should be the energy? Okay, so squaring both sides, so r square, and take this qb over here, will be 2mk. Therefore, kinetic energy will be r square bq divided by 2, and this is m. Why did I write it like this? Observe, kinetic energy is dependent on charge and mass. Radius is same, magnetic field and 2 are constants or the same value. So K is directly proportional to charge, inversely proportional to mass. So if I write down K of alpha by K of proton, ratio of the charge, Q of alpha by Q of proton, inversely proportional to mass. So mass of proton upon mass of alpha. Charge of alpha is twice of proton, mass of proton is 1/4 of alpha, so it will be 1 by 2. But that is not the ratio which is asked. Kinetic energy is asked. Initial kinetic energy is 1, so K alpha will be 0.5 mega electron volt. That is option. Why is it 1? Did I make a mistake? It was supposed to be charge square. So sorry guys. My bad. There was a charge square and b square term over here. While squaring, I forgot to square them. So I was squaring it. So this was square and this was also square. So technically K will be r square b square q square by 2, and this is m. So technically this kinetic energy is dependent on the square of the charge and mass. So K of alpha by K of proton. See this will be Q of alpha by Q of proton square, and mass of proton, mass of alpha, it is inversely related, right? Alpha will come here, proton will come on the top. Alpha has double the charge as that of the proton, and mass of the proton is 1/4 of that of alpha. So this will be 4 by 4, which is 1:1. So kinetic energy of the proton is 1 mega electron volt. So K alpha will also be 1 mega electron volt. So answer is A. Yes. So we have to be very careful when we squared it over here. Yes. Cool. Shall we go ahead? Shall we go ahead? Everybody with me on this? Perfecto. Guys, make sure that you are not disturbing the class and make sure that you are concentrating on the problems out here, because come on, exams are just hardly around the corner, and this is the last time you would want to come to a free YouTube class and then disturb the students who are really serious about it. I mean, like really, you need heights of motivation to come and disturb over here. Just concentrate, guys. Yeah. Now, moving on, next question. This is on your solenoid, and it is being asked what is the magnetic field here. Now, usually the magnetic field inside the solenoid is given by mu naught small ni, but it is for a long solenoid. The problem here is it is not a long solenoid. If you notice, the angles are being made. So if it is making certain angles here, that means the solenoid is limited, it is finite. Else if it was infinite, this side and that side will subtend, a large angle from the center, right? If the solenoid is shorter, then it will start subtending lesser angle, else it will subtend more angle. So the angle subtended from the central line on this side is 60 degree, and on this side it is basically 30 degree. This formula also gets changed a little bit. You will see by 2 over here and sine alpha plus sine beta over here. Does this remind you of something? Yes, of course. Finite wire magnetic field. It was very much similar. So the formula is very similar to the finite wire formula. Yes, finite wire formula, and this formula looks very similar. That sine term used to be there. So that's it. After this, there is no game only. Mu naught Ni by 2 sine 60 sine of alpha sine 60 plus sine of 30. Sine 60 is root 3 by 2. Sine 30 is basically half. 2 becomes common. So mu naught Ni by 4. This 2 into this 2 is 4. Root 3 plus 1. So that is the answer, which is option number A, of course. Got it? So if you know this formula, it becomes easy, or else sitting and deriving there, definitely no chance. Moving on to the next question on your screen. A thin wire of certain length is carrying some current. The wire is bent to form a coil. The radius of the coil is equal to R and the number of turns in it is equal to N. Then which of the following graphs best represents the magnetic field at the center of the coil? That is the question. This is the question. Think about it. You take a wire of length L. Okay, the length is L. You bend it and then make a coil of N number of turns. You bend it and make it into a coil of N number of turns. So let's say the radius is basically R and N number of turns are there. N number of turns are there. I can tell you one thing. The circumference of the circle is 2 pi r. You multiply by N, you will get L. So radius is basically L divided by 2 pi N. That is one thing. Now the next thing is the magnetic field at the center. The magnetic field is given by mu naught I by 2r, and there are N turns, so into N. Instead of R, just put it over here. So you will get mu naught I by 2. So instead of R, just put L by 2 pi N, and this N is over here. 2 cancels. Mu naught I by L is there. Pi goes on the top, and N into N is N square. So that is magnetic field. So magnetic field is directly proportional to N square. It is quadratic and it is going to be increasing as N increases. So there is only one graph like that. It is option number C. Do you see that over here? Magnetic field is directly proportional to N square. So it has to be this particular graph. This graph is with respect to radius. So if you want to cross check for radius, you can do that as well. Okay, I don't think these graphs will match. Okay, perfect. Let's move to the next question on your screen. Electron moves in a straight line inside a, very good question, inside a parallel plate capacitor of charge density sigma. Space between the plates is filled with magnetic field of induction B. Time of straight line motion from this side to this side is asked. Okay, different. Concentrate, bacha. Concentrate, pasangla, please, because how long is the class won't matter. Class will go until 11:30, 11:15 maybe. Okay, point is we have to complete as many questions as possible. After magnetism, you have optics, wave and ray, and after that modern. These are the only 2 units which are left. I want to do as many questions as possible with you, because you have taken up the 2-week challenge, 1000 questions. Sorry, 1-week challenge, 1000 questions. Because it is going in a straight line, this is like a velocity selector. This is like a velocity selector where V is E by B. Velocity selector concept. Velocity selector concept. Remember that? Yes. V is E by B. That is it. Question is how much time it takes to go from here to here. So time is the distance by the speed. So it will be L B by E. Now, what is the electric field? Time of the motion in the capacitor. Time is distance by speed. Yes, okay. So automatically A and C options get eliminated, because if you notice, B is there in the denominator, but our answer has B in the numerator. So this and this automatically get eliminated. I hope you can see that. So either it is this or it is this. Now electric field. What is the electric field inside a capacitor? If charge density is sigma, so electric field is sigma by epsilon naught. So epsilon naught goes on the top. L be epsilon naught by sigma. That is the time taken. So that is option B. Option B. Yes. Not that other one. Okay. So this is the answer. Everybody understood this question? What a brilliant question, right? Combination of capacitors with your velocity selector. Wow. And that too kinematics, time, distance and speed. Brilliant question. Coil 100 turns, radius 10, carries 5, suspended in uniform magnetic field. The field lines making angle 60 degree with the plane of the coil. Calculate the magnitude of the torque. Okay. So there is this coil over here. How many turns? 100 turns. Radius 0.1 meter. Current 5 ampere. And in a suspended vertically uniform horizontal magnetic field. And the magnetic field lines make 60 degree with the plane of the coil. The magnetic field lines of 0.5 Tesla make 60 degree with the plane of the coil. Question is, what is the torque? Now remember, torque on a coil carrying current is given by mb sine theta, where m is magnetic moment. So the magnetic moment is NIA. And B is B, sine theta is sine theta, area is pi r square. Number of turns is 100, current is 5, area pi into r square, so pi into 0.1 square. Magnetic field 0.5 Tesla, sine theta, many people will put 60, but be very careful, theta is always measured with the area vector or the magnetic moment vector, which is here. So the actual angle that you should worry about will be this one, which is 30 degree. So it is not sine 60, it is sine 30. This is the most common mistake which students do. Now the calculation part is simple. You do it, answer you will get it as 4. The answer you will get it as 4 Newton meter. Did you understand? This is the crux of the problem. Many students will fall for that trap because 60 is given, you will take sine 60. No. It's not sine 60, it is sine 30. Yeah, area vector is always perpendicular to the plane. Exactly, my dear warriors. Moving on to the next question coming up on your screen. Galvanometer, voltmeter, ammeter based question regarding sensitivity. Current sensitivity of a coil increases by 20%. Resistance is increased by a factor of 2. Calculate by what factor voltage sensitivity has changed. Wow, what a question. What a question. Yes, approx 4, very good, Vinny Shetty. Awesome money, very nice. I hope the Josh is high. I hope you guys have smashed the like button, and if you are new to the channel, I hope you have subscribed to the #1 JEE English channel, and the channel which we started with a small aim saying that okay, students for South India need a channel in English. Now I'm so happy when I see the analytics. Students from Kashmir, students from Rajasthan, students from Madhya Pradesh, students from Uttar Pradesh, students from Assam, students from West Bengal, students from America, students from Dubai are seeing this channel, and I'm so happy about it. And keep this channel growing, guys. Thank you so much. Make sure you are subscribed. Oh, no problem, Uchuk Puchuk. Zero to Hero is going to be very good series for you. Yeah, perfect. What is this? Sensitivity. Just like V is equal to IR, sensitivity formula is slightly reverse. Sensitivity of voltage into sensitivity of current is not multiplied by resistance here. In fact, it is multiplied by resistance over here. Yep. So what you need to do is okay, so the sensitivity of voltage is SI by R. This is the first time. Now the second time, what will happen? Current sensitivity is increased by 20%. What does this mean? The sensitivity of current, new one, is the old sensitivity plus 0.2 SI, which means it will become 1.2 SI. This is a new sensitivity, will be more by 20%. So you add 0.2 of SI, it will become 1.2 SI. The resistance has increased by 2. So the new resistance is 2 times the old resistance. So when I say S prime V, which will be S prime I divided by R prime, S prime I, the new sensitivity, will be 1.2 SI, and this will be 2 times of R, but this will become 0.6. SI by R is SV. SI by R is basically SV, old. So this S prime V is 0.6 times of SV before. By what factor has the voltage sensitivity changed? So think guys, earlier it was SV, now it has become 0.6 SV. So what is the change? Old one was SV, the new one, the new sensitivity is 0.6 times SV. So how much is the change? How much is the change? 0.4. How much is the delta? Isn't it 0.4 SV? So what is the percentage change? It is 0.4 SV divided by the original, which is SV, into 100, which will make it 40%. 40%? Yes, that is the answer. 40% is the answer. What a brilliant question. And you know why the question is brilliant? Because many students do not know this step. This is the crucial step of the problem. People think voltage sensitivity is current sensitivity into resistance, but it is exactly opposite. Current sensitivity is voltage sensitivity into resistance. If you compare this formula and this formula, you can see they are not similar, but slightly opposite rather, right? So be careful. Yeah. No, the resistance is increased by a factor of 2. The resistance is increased by a factor of 2. So basically the new resistance has become 2 times. That's all. Yeah. I hope this is fine. You are not adding 2 ohms. You have made it 2 times. Moving on to the next one. Magnetizing field produces magnetic flux of density of this much Tesla, 8 pi Tesla in a rod. The relative permeability is how much? This is the question. Come on, think. Which is the formula that you will need? Which is the formula that you will need? Question is, what is the relative permeability? For that, let's find out. Permeability of the medium is B by H. B is given to me. H is also given to me. B is 8 pi. This is basically your B. It is in Tesla. Magnetizing field is basically H. So this is 2 into 10 to the power 3. Bring it on the top, or 8 by 2 is 4. So 4 pi into 10 to the power minus 3. And relative permeability, how do I write? Think about it. Mu m is there. Mu m is there. This is nothing but mu r. This is nothing but mu r into mu naught. Mu r into mu naught, and mu naught is basically 4 pi into 10 to the power minus 7. 4 pi cancels, so mu r will be 10 to the power minus 3 divided by 10 to the power minus 7, which will make it 10 to the power 4, which is option D. Yes, 10 to the power 4. This also tells me most likely it is going to be a ferromagnetic material. It is going to be a ferromagnetic material because mu relatively is very, very, very high. Yeah. I hope this is clear. Everyone, shall we go ahead to the next question coming up on your screen? Yep. These are homework questions which I have kept for you in red. Yes, you can see this question, solutions, everything are given. Okay, this question, standard questions, guys. These are all standard questions. We would have done it at some point of time. Okay, they are very, very simple. I have put the solutions also for all of you. Okay, EMI, AC, electromagnetic waves. Let's go to that also. Yep. All right. Shall we go ahead, guys? Some students have come here for finding true love. Very good. Excellent. You will definitely find true love over here in Vedantu JEE English channel. Just that love will be true only for the session duration. After that, I don't know where you guys find chats. How do you guys... it's beyond my belief. or beyond my understanding, how you guys find people of the other gender and chat in this session, and then you somehow magically give a coded word saying let's meet in that session. Wow, very good, excellent, proud of you. A coil of cross-sectional area 10 square centimeter square is placed in the magnetic field, changes by this much within 5 seconds. What is the current? If 5 ohms of resistance is there, so the current in that will be EMF, which is induced divided by the resistance by Ohm's law. This induced EMF is del phi by del t. So area is given and magnetic field which changes by this much. Okay, so this change in flux is field into area minus 0 upon delta t, this whole thing divided by resistance. Field is given, area is given. Remember, the field has changed by this much in 5 seconds, the area is this much. So flux being magnetic field into area, so this is basically the change of the flux. This is basically the change of the flux. So it will become BA by R delta T. Now substitute everything. So this is basically 4 into 10 to the power minus 2 into 10 to the power 2, whole thing divided by resistance 5, and time is also 5. So this will become 4 by 25, which is 0.16. 4 by 25, which is 0.16. Just check this out. Cool, everyone? Yeah, these two cancelled. If you are wondering why did I not convert it into meters, because this was per centimeter square, this was into centimeter square, the dimensions units got cancelled. That's the reason for that. Next one, same type of question is placed over here. Again, there is some Weber before, there is some Weber afterwards. What is the current? Same logic, guys, just like before. That is why I placed this question right after this. Same thing you do, you will get the answer, except that in the previous question, values were given and your answer came out as numerical. In this particular question, the Webers is given in variable term and number of turns is also given. So you multiply by n and that's how you get the current. Logic is still the same. Is that clear? Will you be able to do this? I just wanted you to see this particular kind of question as well. Cool, guys. Shall we proceed ahead? All right, moving ahead. Next one. A metallic ring is held horizontally and a bar magnet is dropped through the ring along the axis, the acceleration of the magnet. So this is your ring. That's it. It's held horizontally and you take a bar magnet and drop through the ring. Let's say you drop through the ring. It will go like this through the axis. Will the acceleration be equal to g, less than g, more than g? Depends on the diameter and the length. Well, there are two main forces acting on it. One is your mg, but once this magnet moves, what happens is there is magnetic flux which is going to cut through the coil, and this flux changes, which causes induced current, and that induced current what it does is it applies a magnetic force on it. It applies a magnetic force to resist the change. So that's why the net force is less than mg. That's why the acceleration is also less than g. Okay, I hope you get it. Mg, if the force was there, acceleration will be g, but the acceleration is going to be less than g because this force is going to make the net force weaker, less than your mg. I hope this is very, very clear. Yes, option D is correct. Moving to the next one coming up on your screen. A uniform magnetic field is there in the wire of a semicircle of radius r, rotates about the diameter a circle with an angular velocity omega. The total resistance of the circuit is r. The mean power generated per period of a rotation is how much? Okay. First of all, this is a combination of basically, what do you say? AC generation and also power in AC. So two questions or two concepts are combined together. So whenever you take a coil, doesn't matter what the shape is, if you take a coil and you are basically rotating it, okay, from a cell rotates about a diameter, let's say it is rotating like this. The EMF generated is given by BA omega n sine omega t, where this is your E naught. So this E naught, just like the AC generation, you are rotating a coil of certain area A. Magnetic field is B, area is pi r square, small r square, divided by 2 because it's a semicircle. Omega is omega only. Number of turns, no, it's just one coil, so it is just 1. So it will be pi b r square omega by 2. Pi b r square omega by 2, that is your EMF. The total resistances are the mean power generated will be how much? Now the average power, which is the mean power, will be Vrms square divided by resistance Vrms square. This is E naught. So think what will be Vrms? What will be Vrms? It will be E naught divided by root 2. E naught divided by root 2. That is the maximum voltage. So RMS will be by root 2. So this will become 1 by 2r E naught square. That means this whole thing square. So pi square b square r raised to 4 omega square, whole thing divided by 2 square, which is again going to be 4. So this will become pi square b square omega square r raised to 4, whole thing divided by 2 4s are 8, and this capital R over here. This capital R over here. That is the answer. So it comes out as option number B, I believe. Yes, it's right over there as option B. 8R is there in the denominator. Is that clear, everyone? How this was solved? So a lot of people forget to take RMS. Instead of that, they take the maximum. Second mistake is they forget to read the word semicircle, and because of which you forget to divide it by 2. So there are heavy chances that you might miss the 2 2's, either here and here, the root 2, and that's why you might get a completely different answer. So be very careful. Two solenoids, same cross-sectional area, have their lengths and number of turns in the ratio 1:2. The ratio of self-inductance of the solenoid is how much? Now the self-inductance of a solenoid is given by mu naught n square area into length. This is the formula for it. This is basically the formula for it. The solenoids have the lengths and the number of turns, total number of turns, okay. So why not write it as mu naught n square by L square into A into L. LL gets cancelled, so it will become mu naught n square A divided by length. This is your inductance. So your inductance is proportional to n square, inversely proportional to length. So L1 by L2, the turns are in the ratio 1:2. So 1:2 square, inversely proportional to the length. Oh, length is also in the same ratio. So this will be basically 2:1. So this will be 2 by 4, which is basically 1 by 2. This is basically 1 by 2, which is option number B. Yes, that is the correct answer. See, both N1 by N2, N1 by N2 and L1 by L2 both are given to be 1:2. That is the catch over here. So when you take N square, so 1 by 2 square, and when you take 1 by L, so it will become 2 by 1. So the ratio will become 2 by 1. I hope you guys got that over there. So you need to be little bit careful. Moving to the next one. A small piece of metal, volume this much, has magnetic field this much inside it. The magnetic energy stored in the metal is this many joules. Find the value of alpha. If there is a magnetic field going, it has magnetic energy density. Multiplying it by the volume will give me the total magnetic energy. The total magnetic energy is magnetic energy density into the volume of the cube. The magnetic energy density is given by B square by 2 mu naught, and the volume is given. The volume is basically given. So B value, you know, how much is it? 4, and mu naught is nothing but your 4 pi 10 to the power minus 7, and the volume is oh, but this is not just mu naught. This has to be just mu also because there is relative permeability. So into 20. So rather I will put into mu r. So this will make it into 20. Relative permeability is given. And volume is 10 centimeter cube. So it is 10 into 10 to the power minus 6. 10 into 10 to the power minus 6. So you will get something by pi joules. Something by pi. Pi is there over here. Solve this and see if you get the answer as, I don't know, they are getting the answer as 10. Yes, the answer as 10 over here. Just check this out. Yes, because 4 and 4 will cancel. 2 and 2 will also cancel with another 4. Just check if you get 10 by pi joules. So answer is basically going to be 10. Is that okay, everyone? Shall we go ahead? Next question. Full energy, guys. Full energy, full josh. Don't give up so easily. Your dream is very close. Like they say in the vehicles, the objects in the mirror are closer than they appear. The exam is much closer than it appears. So when the exam is so close, even your dreams are very, very close. So it's up to you whether you want to make your dream virtual or real, right? So if you want to keep your dream virtual, fine, go ahead. But you want to make your dream real, then make sure your actions are accordingly, justifying it. Because you cannot expect a good rank, you cannot expect a good result without good efforts. If you are thinking that just by dreaming or, if I just do this minimal effort, I will get a good rank, no. Then what about that student who has put in that extra effort, who has solved so many more problems than you? Does it justify it? Definitely not. So put in that 100%. Everybody is competing right now. And I don't want any student of Vedantu JEE English to stay behind. We have to push ourselves. Next one, the coil of resistance, self-inductance has connected to a AC source, the phase difference between the voltage and the current. So it's a LR circuit connected to AC. So first find XL, which is omega L. Omega is 2 pi. F is 200 by pi. Inductance is 1. Pi cancels, so it will become 400 ohms. That is your XL. Resistance is basically 200 ohm. Yeah, to a source of this thing. Right, perfect. Now, what do you do over here? Why do I feel that something might go wrong over here? 1 Henry, okay, omega into L, omega is 2 pi F, source frequency is 200 by pi. Okay, this is 400, this is 200. Now, basically, if in the resistance triangle, XL is pointing up, resistance is pointing horizontal. So this is basically 200, XL is basically 400, this will be 5, and this will be the exact phase difference between the voltage as well as the current. So from this you can see tan of phi will be 400 by 200, which is 2 by 1. So it is basically 2. So phi is tan inverse of 2. Tan inverse of 2. I don't see tan inverse of 2. It can't be 45, but they have given the answer as 45. Did I? Wow, there is a typing mistake. See, this was 200 by 2 pi. Wow, very nice. How did that 2 come? God only knows. So they have done a calculation mistake and given the answer as 45, but the correct answer is tan inverse of 2, guys. Okay, thank you so much. Right, correct. So ignore these options. Ignore these options. Okay, so the correct answer will be tan inverse of 2. Alrighty, moving ahead to the next one. Voltage is given, current is given, power dissipated in the circuit is how much? Thank you, Sonal Pandey. Love you too. Love you all, actually, guys. I mean, really, because I have a lot of hopes on you. I've been treating you like, small Pandus and Champas who have grown up to come over here and, who are going to nail it in the next few days. So keep it up, guys. And let's see if you can answer this next question. So Jiva, it will not be 45. Yeah, because they had given a printing mistake over there. Yeah. So To find the power dissipated, what we need to do, to find the power dissipated, it is nothing but VRMS, IRMS into cos of phi. That is the correct formula. VRMS is V0 by root 2, IRMS is I0 by root 2, cos of phi, here it will be cos of pi by 3, because that is the phase difference. This is sine, phase difference is pi by 3. V0 is basically 100, I0 is basically also 100, this root 2 into 2 is 2, cos of 60, cos pi by 3 is 60, is basically half. So how much is it going to come out to be? Yes, very good, 2.5 watts if you get it. 50, oh, this is volts and this is milliamperes. Yes, this was milliamperes. So into 10 to the power minus 3, this milli is also there. So it will make it basically 100 into 100, 10 to the power 4 into 10 to the power minus 3 will make it 10, 2 2s are 4, so it will become 2.5 watts. 2.5 watts, yep. Very good. Crazy guys, crazy. Yes, I am tired, Shruti, because 6 hours I took class in the morning from 11 o'clock to 5:30 continuously. I solved around 200 problems on the NEET channel, I think. Yeah. So we reached, I think, yeah, 667th page in that series in NEET channel, and then I came over here. I had my lunch at 5:30. I have not yet had my dinner. I'm going to have my dinner after this session. Okay, chalo, let's go ahead to the next question. I don't want to share my problems with you because you also have your problems. Then you will be also sharing, sir, yes sir, I also have this problem. Yes, we all have problems, but we are all working hard. Which of the following is the shortest wavelength? This is simple. X-rays, microwaves, gamma rays, or radio waves. The one which has higher frequency, low wavelength, low frequency, long wavelength. So which is the correct answer, guys? Short wavelength, small wavelength means high frequency. Highest frequency is gamma. Highest frequency is gamma. Then comes X-rays, then comes microwaves, then comes radio waves. You should know the correct order of all the different rays and the ranges, their applications, how are they formed, where are they used. The table is there in NCERT, very, very important table. There are good chances that you might see that. Yes. All right, moving ahead to the next question. What is the refractive index of the medium? Yep. In terms of permeability and permittivity, it won't be this or this. Both will be there. Either it is A or B. So speed of light in vacuum, right? C naught. I can write it as 1 by root mu naught epsilon naught. C in the medium will be 1 by root mu of the medium epsilon of the medium. So refractive index, so usually we use mu, but I will use n over here, will be speed of light in vacuum upon speed of light in the medium. So it will be 1 by root mu naught epsilon naught by 1 by root mu, wow, mu epsilon. So this will become 1 by root mu epsilon and mu naught epsilon naught. That's the refractive index. Yes, option B is the correct one. Simple division. If you know this formula, easily you can get it. And yeah, it has also combined ray optics along with this. Now these are homework questions. Yes, we have come to the red zone. That means we have to keep this as homework. Yes, all these questions I'm going to give it to you as homework, 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 homework and homework. Yes, we are going to go to optics, both wave and ray. So let's go to ray optics and wave optics. Get ready guys. Last 2 units to complete. Don't give up. Warriors, fight it. Yes, let's go to the first question of ray optics coming up on your screen. The object is placed at a distance of 40 cm from a concave mirror of focal length 15. The object is displaced through a distance of 20 towards the mirror. By how much distance the image is displaced? Okay, it's a concave mirror, right? All right. So we have a concave mirror and the object is placed at a distance of 40 centimeters over here. So using 1 by V plus 1 by U is equal to focal length 15. Concave, that means it will be minus 15. Agree? Because it is a concave mirror, what will happen? The focal length will be minus 15, right? So solve this and see what is the value of V that you get. in this first case. Take it on the other side, it will become 1 by 40 minus 1 by 15, right? So what is the LCM going to be? Check it out. What is the LCM going to be? 240, let's take it, 240. So this will become 6 minus 15, 16. So this will become 10 by 240, 0 cancels. So you will get V1 as 24 centimeters. Just check this out. V1 is coming out as positive 24 centimeters. That means the image in the first case is formed at a distance of 24 centimeters over here. Okay, fair enough. Now in the second scenario, what is happening? The object is moved through a distance of 20 centimeters towards the mirror. Okay, let's draw it again. Towards the mirror. So that means the object is now at a distance of 20 centimeters. So again, if I use mirror formula, 1 by V plus 1 by U, which is minus 20, is equal to 1 by minus 15. Focal length will be negative. So 1 by V2 will be 1 by 20 minus 1 by 15. So LCM is 60, let's say. So this will go 3 times, this will go 4 times. Correct? Perfecto. Yeah. By 20. Yes, perfect. So did we do something wrong? No, it's fine. So it is coming out to be minus 1 by 60. Just check this out. And I think there was a mistake over here. I just realized this was minus 10. This was minus 24. So actually speaking, the image was somewhere here only. The image was somewhere here only. And this distance was 24. This distance was 24, right? So yes. So here also I will get V2 as minus 60 centimeters. That means the image is formed somewhere over here. And this is basically 60. Now the actual question. The image is displaced by how much? If you measure everything from the mirror, earlier the image was 24 away and now the image is 60 centimeters away. So what is the displacement of the image? It is 60 minus 24. Agree guys? Everybody with me? Yeah, so it is going to be 36 centimeters. Perfect. 36 centimeters. Got it? How we did it? Okay, take the two scenarios, find the image positions and yeah, measure everything from the mirror. 60 away, 24 away. So the change is 60 minus 24, which is 36. So that's the displacement. Moving to the next question, I think it's based on polarization. A beam of unpolarized light of certain intensities pass through a polaroid and then through another polaroid oriented so that the principal plane makes an angle of 45 degrees relative to A. The intensity of the emergent light is how much? Okay, so unpolarized light. So this is unpolarized light of intensity I naught is going to pass through a polarizer whose pass plane is like this. Let's say I call that A. So the light which comes out of it is going to be polarized of intensity I naught by 2. The next polarizer's principal axis makes 45 degrees with it. So the next polarizer makes an angle of 45 degrees with it. So the final light is also polarized, but by Malu's law, the intensity will be multiplied cos square angle times. So it will be I naught by 2, cos 45 is 1 by root 2. So 1 by root 2 square, which will make it I naught by 4. So I naught by 4 should be the answer, which is option number B. Yes, that is correct. Is that cool? Shall we go ahead to the next one coming up on your screen? Yeah, it is 36. No, why will you put minus? That minus is not minus. It was dash. It was like answer 36. Answer, violet. Like that. It was a hyphen. It was not a minus. So don't think the answer was minus 36. It was a hyphen symbol. Okay. Oh my God. Crazy. Moving to the next one. Horizontal ray of light is incident on the right angle prism, angle 6 degree. The refractive index of the material is 1.5. Then the angle of emergence will be how much. The ray of light is incident horizontally. The diagram doesn't even closely resemble the actual ray diagram, so it's better to draw a proper ray diagram over here. This is how the prism is. This is basically 6 degree. Now what is happening is a ray of light is going horizontally. So if the ray of light goes horizontal, it will fall perpendicular. So nothing will happen to this light. It will continue its journey like this only. So there is no change in its path. But over here, it is falling at certain angle, like you can see, and because of which it will get refracted and it will probably go like this. It will probably go like this. Had the light ray continued its journey, it would have continued like this. This is how it is. So this is the original direction of light. This is the final direction of light. So this angle that you see over here is the angle of deviation. And that angle of deviation is A into mu minus 1 for a thin prism. Angle of prism 6 degree, mu 1.5 minus 1. So it is 6 into 0.5, which is basically 3 degree. Now immediately you will answer, sir, 3 degree, but 3 degree is not even there in the option. 3 degree is not even there in the option. Yes, thank you, night howlers, sir. I'm truly saying because of you I'm able to do some problems. Very good night howlers. So now what is the issue over here? Because question is angle of emergence. So this is angle of emergence. You will be like, oh wow, but how do I know this angle? No issue at all. See what we can do. This was 60 degree, this is 90 degree. So this is complementary of that. This is complementary of that. Complementary of 6, right? Which will be basically 84 degree. So this angle will be again 6 degree. This angle will be 6 degree because I know this should be 90 degree. This should be 90 degree. Complementary of a complementary is the original angle. Agree? So if this is 6, opposite angles are equal. So this is also 6 degree. So hence the final emergent angle will be 6 degree plus this angle, which is 3 degree, which is 9 degree, which is option number A. Yes, perfect. Option number A is the correct answer. Cool. Shall we go ahead? Yes, you can sleep if you want to. Nobody will stop you from sleeping, but few more questions only are there. Few more questions, okay? If you can control and stay awake till more 15-20 minutes, our job will be done. Glass slab of certain thickness, same number of waves as 12 centimeters of water. When both are traversed by the same light, if the refractive index of water is 4/3, refractive index of glass is how much? Okay. See what is happening over here. There is a glass slab, same number of wavelengths as 12 centimeters of thing. So if you have this as 10 centimeters, there is some wavelengths over here like this. If the number of waves are n, the wavelengths are lambda 1. So lambda 1 into n is basically 10 centimeter. That is what this first part says. And when you pass the same light, but the wavelength will change because the medium changes. So this has different wavelengths over here. Let's say lambda 2. Same number of waves are there, but the thickness is 12 centimeters. So lambda 2 into n is basically 12 centimeters. So from this and this, you can clearly see that lambda 1, 10 centimeters is basically 0.1, is equal to meters, is equal to lambda 2 by 12 centimeters, which is 0.12 meters. That is what I am getting, lambda 1 by lambda 2. Okay, now what do I do with this data? These wavelengths are the original wavelengths by the refractive index. So lambda 1 is technically lambda by refractive index of glass, this divided by 0.1. Same way over here, lambda 2 is the original wavelength divided by refractive index of water. Yeah, so this is divided by 0.12. Lambda cancels. Lambda cancels. So what I have over here is 0.1 into mu g is equal to 0.12 into refractive index of water, which itself is 4/3. This goes with the, okay, we'll do that later on, no issues. So mu g, basically we have to find mu g. So what is mu g, guys? What is mu g? Take reciprocal, forget the 1. So mu g will be this whole thing divided by 0.1. So 0.12 multiplied by 4, 3 is there below, and take that 0.1 over here. Take that 0.1 over here. Shift the decimal, it will become 1.2. Then 3 goes with 1.2, 0.4 times 0.4 into 4 will become 1.6 should be the answer. Yes, that is correct. This 1.6 is what the answer should be. Such a brilliant question. Asked it in a different way. Wavelength related to the refractive index, time, distance, speed kind of question, where some wavelengths are fitting in some slab, but the number of wavelengths are the same because wavelengths are different and slab thickness also are different. What a brilliant question, guys. Moving to the next one on your screen. This kind of questions were also commonly asked in the first attempt, so you should be just careful about these. I'll tell you why. 1 by f effective will be 1 by f1 plus 1 by f2. So it will be 1 by 20 plus 1 by 25. LCM is 100. This will become 5. This will become 4. This will become 9 by 100. This will be 1 by FE. So FE will become 100 by 9. But 2 thin lenses, 20 and 25. Okay, fine. No problems. Now, what you will do is, this is in centimeters. If you convert it into meters, this will be 1 by 9. This will be basically 1 by 9 meters. So this is the crux of the problem, where you convert it into meters, or else you will get a completely wrong answer. Now power is 1 by Fe. So it will be 1 by 9, which is basically 9 diopters, which is option C. Or else you will get something else. Is that okay? All right. Moving to the next question coming up on your screen. There is some prism of certain angle. It is placed at some distance from the object. What is the distance of the image from the object? Prism angle is this much. This is by far the best question of the prism. Very few people can solve this. If you are targeting 99 percentile, then only you should be able to solve this. Let's see how many of you can solve this, guys. I'll tell you what. There is this prism. Over here. Okay, having some small angle, 5 degree. You have some object. The rays from this particular object will probably go, refract, go like this, refract like this. If you extend it backwards, probably this is where you will get the image. Okay, so question is, how far is the image from the object? Seems like a very difficult, strange, weird looking question, not of any standard type. But I'll tell you what the logic behind this is. Okay, tell me one thing. When you take a glass slab, if you place an object here and if you see it from here, what happens? Quickly answer. The image of the object comes closer to you. There is an apparent shift, and that apparent shift is thickness into 1 minus 1 by mu. Is that right? Very good. Now imagine the slab is very thin, very thin slab. So if you place the object, where will the image be? The image will be over there only. The apparent shift will be negligible. Now these are two parallel lines, parallel surfaces. The shift is negligible. Now just imagine, it is not parallel, but it is making a small angle. It's very thin. So the object is here, the image won't come closer, but it will get deviated. Basically deviated, because what a prism does is deviation, not shift. It's a thin prism. So you will see that the amount by which the light rays got deviated, that will basically cause the shift in the image, not by bringing it closer, but by moving it sideways. In fact, you can think as if this thin prism was like this, this object was here, this was some distance, and the image is now here, and the angle by which it has rotated is basically delta. So now you have to find this distance, let's say x. This is like your arc. So x is like the length of your arc, which is r into theta. The object is 10 centimeters away. So basically this is 10 centimeters. So r is basically 10 centimeters. Theta, we can find, na? What is it? Angle of prism is given. So theta is a delta, which is a into mu minus 1. A is 5, mu is 1.5 minus 1, so 0.5 into 5, 2.5 degrees, but don't leave it in degrees, convert it into radians. How? Multiply by 2 pi divided by 360. So 2 into 2.5 is 5. So 5 pi by 360 radians. So put it over here. 5 pi by 360. 0, 0 cancel. So 5 pi by 36 is the answer. 5 pi by 36. Clear, guys? What a lovely question. Understood? The concept comes from apparent shift. The moment you make it thin slab, the image does not come any closer. So the image is still 10 centimeters away, just that it gets shifted because the rays get deviated. That is all that is happening in this. Moving to the next one. Two waves have intensities 9:1, the ratio of maximum and minimum intensities. So assume one intensity is 9I, other intensity is I. So to find maximum by minimum, common model of question, use this formula. Root I1 plus root I2 is maximum intensity whole square, and minimum intensity is root I1 minus root I2 square. So root I1 means root 9I, root I2 means root I, and this is root 9I, and this is root I. Square it. So root 9, all these i's will get cancelled. Root 9 is 3, this is 1, this is 3, this is 1. Square it. 3 plus 1 is 4, 3 minus 1 is 2. Square it. So 2 square, which is basically 4. So 4:1 should be the answer. Yes, option D is correct. Cool? No, this is not C for Cap2. Unfortunately or fortunately, this is option D. Moving ahead to the next one. In YDAC setup, the two slits are covered with thin sheets, thickness T and 2T, refractive index 2 mu and mu, the position of the central maxima. So you should know the shift formula. What is the shift formula? Shift formula is T into mu minus 1 into D divided by small d. This is the formula for the shift. Because there are two slabs, two sheets in front of each sheet, right? So one will try to move it this way, other will try to move it the other way. So accordingly, you will find the answer. This is due to any one of it. It will have any refractive index and any thickness correspondingly. So the net shift, which is delta 1, which might be up, and delta 2, which might be down, given by thickness 1 T, refractive index 2 mu minus 1, capital D by small d, minus thickness 2T, refractive index mu minus 1 into capital D by small d. Few things are common, like T D by small d, and here you have 2 mu minus 1 minus 2 mu plus 2, okay. 2 mu minus 2 mu gone only, minus 1 plus 2, 1. So TD by small d. TD by small d is the correct answer. Yes, that is correct. You can see that right over here. Surprisingly, mu just got cancelled out. That is the best part about this. Cool, guys. Who is Cap2? Money 007. Everybody, come on, spam who is Cap2. Fast. Money 07 needs who is kept to? Everybody should answer. Yeah, what are you guys doing? These are homework questions. Yes, red ones are homework. Orange ones are, you can see the color difference. I don't know. I can see it. All these are homework questions. Homework. Where are the answers going to be? In the PDF. Where is the PDF going to be? In the Telegram group. Where is the Telegram group link going to be? In the description box. Right? It's like the universe contains the galaxy contains the solar system contains the earth contains your house. Same way, this session contains questions and homework. These homeworks are there in your PDF. PDF is there in the Telegram. Telegram is there in the description box. A little bit effort you do, right? Moving on. First question, semiconductors, guys. Ready for it? Semiconductors, modern physics. Last section. See, now you should understand why few students only get 1%, that top 99 percentile. We started with full josh. Yes, or 140 live watching. Now it came down to 60 live watching. Understood? Half of the people give up. After this, maybe even more half might give up for tomorrow. So that is why it is called as a challenge. But can you survive? Can you watch? Can you solve? Till the end of the exam, till the last minute, 3 hours also. Are you having the same patience? Are you having the same focus? Are you still with that same energy? Many people give up after 1 hour. Many people give up after 2 hours. Many people start making silly mistakes after 2 hours. Lot of negativity peeps in, right? So that is what the challenge is. Sitting continuously and solving. Because you know what is at stake here. Your rank, your college, your branch, your career. Simple. Moving on. Next question on your screen. Here it is. Last section, starting now. According to the Einstein's photoelectric equation, the graph between kinetic energy of the electrons and the frequency. Remember there was a graph which you study of stopping potential versus frequency, and that graph goes like this, goes over here, goes like this for different materials. The slope, remember, was h by E. So now just multiply this Vs with E. What will it give you? Kinetic energy. So that graph will also be like this. Will it be this? Will it be passing through origin? No. Will it be above like that? No. It will be like this. See, the options are so confusing. Everything is a straight line, but where is it going from matters. I compared it with this and I got the answer. So the answer will be option D. Option D. If you use a different material, it will shift sideways like this and like this. That's all. Slope will be same. Wow. So many of you gave answer D. Money. Very good, Umesh. Emoku. Gokul Krishnan. Very nice. Game over Tamil. Awesome. Awesome. Chakrada. Why not C? C is passing through the origin. No, you will never have zero kinetic energy, zero frequency. That means the work function is only not there. Work function will be 0. So that is not correct. Every metal will have some work function. After absorbing some neutron, nucleus breaks into 2 nuclei, and the de Broglie wavelength of nuclei with mass m1 is lambda. What is the de Broglie wavelength of the other nuclei? This is a very good question. So there is a what is it? There is a big nucleus. Okay, it absorbs a neutron like this, and after this what happens is it breaks into 2 parts. One is m1 and the other one is 5m1. This goes here, this goes here. Question is, if this guy's de Broglie wavelength is lambda, what is the de Broglie wavelength of this guy, lambda prime? You know the best part about this question? See this. This was at rest. So the total momentum initially will be 0. So after it explodes also, the total momentum should be 0 only, right? Total momentum should be 0. So whatever is the momentum this side should be also the momentum that side, and they should be equal in magnitude. And remember, momentum is h by lambda. Momentum is h by lambda. These both should be equal. That means lambda prime should be lambda. As simple as that. So it is D option. No wasting of time. Chumma random things are given to you, 5m1, m1, all these things are waste information, useless pieces of information. Don't waste your time there. Yeah. Money 07, Naku Telugu Telsu, little bit, not so much. Okay. Yeah. Moving on, next question coming up on your screen. Here it is. The ratio of the areas of the electron orbits for the first excited state to the ground state for the hydrogen atom is. Ooh, okay. Ratio of the areas for the first excited state to the ground state. Area is pi r square. Pi r square. So r1 by rg. Radius, remember, is proportional to n square. So this will be nothing but first excited state square, ground state n square, because radius is proportional to n square. So this will be n1 by ng whole raised to 4. My goodness. First excited state n is 2, ground state n is 1, they raised to 4. Square is 4, 4 square is 6. Yeah, this should be 16. Just check this out. Yes. Perfect. 16 is to 1. 2 cube is 8. 2 raised to 4 is 16. Yes, option B, 𝑬𝒑𝒐𝒓𝒆. Very good. Yes, Pradeep. No. It is not D. Be careful. That n square is also there. Many students make that mistake. You forget that n square. So square of the square will make it raised to 4. Wow, what a question. A, B, C are the energy levels, some random energy levels. If an electron goes from here to here, wavelength is lambda 1. If it goes from here to here, lambda 3. If it goes from here to here, lambda 2. What is the relationship between them? The best part is, they do not tell you what is C, B and A. Some energy levels, you just know C is more than B more than A. That's all. That is the beauty of this question. Question is, what is the correct relationship? One thing is there. If I take the energy difference between these two, which is energy difference between C minus energy difference and A. The difference of the energy is the energy of the photon which is emitted. So it is energy of the photon which is emitted. So it will be hc by lambda 3. That is the first thing. Next thing, if I take the energy difference between these two, which is energy difference between C minus energy difference in B, I'll get the energy of the photon 1, which is basically hc by lambda 1. Same thing if I take the energy difference between B and A, I will get the energy of the photon emitted here, which is E2, which is hc by lambda 2. Now the best part is over here, just add these two. I think you will get this, because EB will cancel. EB will cancel. You will get EC minus EA. Correct? You will get just what? EC minus EA is hc by lambda 1 plus hc by lambda 2. But EC minus EA is nothing but hc by what is it? Lambda 3. So that continues to be hc by lambda 1 plus hc by lambda 2. You can now see hc gets cancelled. So you will get 1 by lambda 3 is 1 by lambda 1 plus 1 by lambda 2 like resistors. So lambda 3 will be lambda 1 lambda 2 divided by lambda 1 plus lambda 2. So that is option number B. Yes, perfect. That is correct. Option B. How you say E1, E2, E3? Pradeepa, that is...
I found this on the web for 1 plus...
Shut up my phone, please. Okay. So guys, this is Bohr's postulate. Remember, the energy difference between the orbit is the energy of the photon which is emitted. Bohr's postulate. That's why theory, reading and application and understanding is important. The difference of the energy is the energy of the photon which comes out. That is why EC minus EA is nothing but your lambda 3, the energy of photon number 3 which is emitting lambda 3. Got it? Same thing. For these two, it will be this wavelength. For these two, it will be this wavelength. Energy difference. Is that okay, Pradeepa and others? Board exam question, is it? CBSE question, wow. CBSE questions also are so difficult. This time physics paper so difficult, no? Which of the following graphs represents correctly variation of current with intensity and incident radiation? Current and intensity, yeah, directly proportional. There is nothing great about it. Current is always directly proportional to the intensity. More photons, more intensity, more electrons being ejected, more is the current. That is the flow of logic. Flow of logic. Cool. Shall we go ahead to the next one on your screen? Here it is. Transition from 4 to 3 emits ultraviolet. What will be the transition for infrared? Do I need to remember this? Maybe not. This is 1, this is 2, this is 3, this is 4, this is 5. 1, 2, 3, 4, 5. From 4 to 3, wow. 4 to 3, ultraviolet comes out. From 4 to 3, ultraviolet, from 4 to 3, ultraviolet rays are coming out. Infrared will be obtained for what? Okay, now one thing, ultraviolet is short wavelength. Ultraviolet is short wavelength. That means the frequency is large. So frequency of UV is larger than the frequency of infrared. So that means the energy of ultraviolet photon will be more than the energy of the infrared photon. That means the energy difference between the orbits for emitting ultraviolet will be also more than the energy difference of the orbits to emit the infrared. Interesting. So basically, what is that energy difference which can be smaller than 4 and 3? Remember, these lines are not equally spaced. If you go from 2 to 1, I don't think that is the answer. 2 to 1 is very huge. If you go from 3 to 2 also, it is huge. 4 to 2, oh my goodness. Oh, sorry, where is it? 4 to 2 is also very huge. Doesn't make sense. 5 to 4, yes, this is smaller. 5 to 4, this is very small as compared to ultraviolet. Slightly, the gap is less. So this can emit infrared. That is the correct answer, which is option D. Did you understand how did we solve this? The crux of the problem is showing the energy lines not equally spaced. This is more, less, less, less. So this is more, this is even less, next will be even less. So that is how I was able to predict, and that is the level of thinking needed for this question. All right, moving for the next one. Hydrogen atom makes a transition from 2 to 1, emits a photon. The photon strikes a doubly ionized lithium, that means hydrogen-like only, in excited state and completely removes the orbiting electron, the least quantum number for the excited state of the ion for the process will be. It's in some excited state. What excited state it is, that is something which is basically not given. So what do we do in that case? Let's see. First, from n is 2 to n is equal to 1 for a hydrogen atom, what is that energy difference which will come out? Hydrogen emits a photon. So the energy difference which will be E2 minus E1, which is transition from 2 to 1, right? Yeah. So minus 13.6 divided by 2 square minus 13.6 divided by 1 square. This is the energy of the photon which will be coming out of it. So the energy of the photon will be 13.6, 1 minus 1 by 4, which is 3 by 4. Just do the math and see how much is it coming out to be into 3 by 4. Just check it out. I think it should be 10.2, the standard value that you usually get in many problems. Just check this out. Yeah, this is the energy of the photon which is going to come out. So what has happened is from an atom, from 2 to 1 electron transited, so it emitted a photon. So it emitted this particular photon when it went from 2 to 1. Now this photon hits a doubly ionized lithium atom. So lithium atom is over here, and there are many orbits. I don't know which orbit it hits, okay, which orbit it will hit. This is your lithium atom. This photon will basically be absorbed maybe somewhere here, and it makes the transition happen, and it removes the orbiting electron completely. So if it removes the orbiting electron completely, it is going to ionize it. It is going to ionize it. So can I say this 10.2, this 10.2 should be, this 10.2 electron volt should be more than 13.6 Z, which is basically 3 square by your n square, at least. I don't know that n. What is that n? I don't know. To remove it, the energy required will be 13.6 Z square by n square. Lithium Z is basically 3. So basically n square should be more than 13.6 into 4 divided by 10.2. So roughly, how much do you get the value of, n? Come on, do the math and tell me. Just do the math and tell me the value of n. Just check it. If you get it as 4 again, just see if you get it as 4 again, right? If you get it close to 4, that is it. Yep. Is that okay, guys? Everyone? Captivity is 9. Oh my god, what did I do? Happens. It's a late night, so it is 9. What is wrong with me? So n is more than the root of, n is more than root of this will become 3, and root of 13.6 divided by 10.2. So n is more than 3 into 1 point something. I think it will come out to be more than 4. It will 3 point something it will be. So basically n will come out to be 4. Some 3 point something will be there. 3 point something will be there. 3 point something, because 13 by 10 is like 1.3. 1.3's root will be 1 point something, very small. So it will be 3 point something. So n should be more than that. It has to be an integer, so it will be 4. Yeah, it is 4. Correct. Moving to the next one. Absolute zero, silicon acts like a, come on, last part, guys. Absolute zero. Yes. Absolute zero. Silicon is a semiconductor. At zero temperature, no energy, thermal energy. So all the electrons will fall back to the ground state. Will fall back to the, valence band. No electron will be jumping to the conduction band. So they're all settled down. They're all cool. So it will act like an insulator. Yes. So semiconductors act like insulators at 0 Kelvin. That is the logic. The depletion layer in the p-n junction region is caused by, standard theoretical question. The depletion layer, everybody spam it. The depletion layer in the p-n junction. So what happens? Depletion meaning there is electrons and holes which have left their positions. Why does that happen? Because when you get p and n together, the ends get attracted by the holes. So the electrons move towards the p side and the holes jump towards the n side. So there is a diffusion happening in that particular place. So diffusion of charge carriers, which leads to diffusion current, and the opposing current is called as the drift current. That is how you do it. Yes, I hope that is clear. Very good. Moving on, next question. Oops, I showed the answer. It's okay, even if I show the answer, fine. So question is, what is the dynamical resistance of the p-n junction? Dynamic resistance is different from your regular resistance. Resistance regularly is V by I. Dynamic resistance is delta V, rate of change of voltage with the current. Slightly different, be careful. So delta V is basically, you can choose this one. This is your delta V and this is basically your delta I. So delta V is basically 1 minus 0.8 and delta I is 10 minus 6, which is 0.2 by 4. but that is in milliamperes. So this is into 10 to the power minus 3, and volts is volts only. So it goes on the top, becomes 10 to the power plus 3. So this will become 2 by 4 into 10 to the power 2, which is 0.5 into 10 to the power 2, which is 50 ohms, which is option D. Yes, that is correct. That is the dynamic resistance, guys. Moving to the next question. Two PN junction diodes connected in the electrical circuit, resistance to the battery, okay, 4 ohms, 12 volts. What will be the current in the circuit? In this circuit, when this positive terminal is connected here, this diode is going to be in the reverse bias, so no current at all. So the current which will flow will go like this, like this, like this. Nothing will go here, like this, like this, like this, like this, and back over here. So the current will be voltage divided by total resistance, which is 4 plus 2. Diode has no resistance, so negligible. So 12 by 6, which is 2 amperes. So 2 amperes should be there. Yes, option C. Cool, guys. How we solved it? Yep, very good, very good. Moving ahead to the next question on your screen. The logic gate is equivalent to which gate? Standard type of question based on De Morgan's principle. You should know this principle. A dot B bar is A bar plus B bar, and A plus B whole bar is A bar dot B bar. So the dot becomes plus, plus becomes dot. The whole bar gets separated out over here. That is the logic. So use the De Morgan's principle. This is basically A bar. This is basically B bar. This is a AND gate with a NOT in front of it. So when you AND A bar with B bar, it becomes a dot. A bar and B bar. And then you NOT it, that means put a full bar. So when you have a full bar, separate them out. So what do? You separate them out. And the dot becomes a plus. What are those quantities which are separated? A bar and B bar. A bar and A bar bar is A, B bar bar is B. So it is A plus B. So that means it is basically a OR gate. Plus means OR. So answer is B option. Is that right, everyone? Hey, who is that putting it as C? Who are those people putting it as C? That is wrong, guys. That is wrong. Okay, very good. Yes, this is in red. So these are all homework questions. So few homework questions for all of you. Okay, simple questions on modern physics. Everything is there over here. So I think you will be able to solve this. These are standard pattern questions, high weightage questions. I hope you are taking part of the 1 week challenge. Tomorrow you're going to have your maths and chemistry questions, and day after tomorrow 12th standard mock test. So get ready for the 12th standard mock test which is coming up, and then we'll have full syllabus mock tests followed in this particular week. Okay, so get ready, guys. 1000 questions, you are doing it and you can do it. And make sure you comment down in the video that you loved this video, and smash the like button, comment, share, talk about Vedantu JEE English, talk about Captain Shreyas to all your friends, to all your schoolmates, to your crush. Maybe your crush also knows about Shreyas Sir. Oh no? And then you'll be like, hey, you also know Shreyas Sir. Oh yeah, hi. By the way, this is Raj. Okay, so cool. Great. Bye bye, guys. Take care. Captain Shreyas signing off. Hasta la vista. Good night. Have a great night. And just 6 minutes to midnight. Sleep well now. Okay.